Hey guys, this is Kalindi and you are watching the channel Physo Freak. Here we discuss some great concepts of physics. In the previous video we learned about the nature and sources of light, and today we will discuss about the properties of light. So let's get started. The first property which we are going to discuss is velocity of light. Many attempts have been made to measure the velocity of light, and today we have reached the most precise value of speed of light. But have you wondered who made the first attempt and what method did he use? Well, it was in 1667 when Galileo gave it a try. So, what was the method? Two observers were made to stand on tops of two hills about 1.5 kilometers apart. Both A and B had to give a flash of light one by one. Then A had to measure the time interval between these two instants of time. However, the interval could not be found. So said no. But from this, Galileo concluded a very important fact, that velocity of light is finite, but it is extremely large. 8 years later, in 1675, Danish astronomer Rømer succeeded in measuring the velocity of light. The calculation included the diameter of Earth's orbit and the time required by the light to travel along the diameter of Earth. The calculated value of the velocity of light, that is c, was equal to 2.3 into 10 raised to the power 8 meter per second. This value is slightly lower than the actual one. After many experiments, today we have the most precise value of speed of light, that is 2.99 into 10 raised to the power 8 meters per second, commonly known as 3 into 10 raised to the power 8 meter per second. Now we will talk about the spectrum of light. So we know that light is an electromagnetic wave, and a wave has its frequency and wavelength. When we arrange various electromagnetic waves in a sequence based on their frequency and wavelengths, we get a special array which is known as spectrum of light. This spectrum contains wavelengths ranging from a few kilometers, which are radio waves, to the order of 10 raised to the power minus 12 meter, which are gamma rays. Now the question arises, what can we see? The part of spectrum which can be detected by humans is called the visible range. This visible range lies between deepest violet to deepest red color, and the wavelengths range between 4000 angstrom to 7800 angstrom. As you can see here, this is the whole spectrum of light. The visible region lies between the ultraviolet and the infrared region. As we move towards the right, the wavelength is increased and the frequency is decreased. The three regions, namely visible, UV and IR, put together constitute the optical radiations. The highest wavelength is observed in radio waves, while the highest frequency is found in gamma rays. Next property is wave-particle duality. On one hand, light is considered to be a wave having frequency and wavelength, while on the other hand, we consider it as a collection of photons having energy E and momentum p. If we talk about the reason behind this duality, it may be due to the wide range of frequencies found in the electromagnetic spectrum. At lower frequency end, there lie radio waves whose wavelengths are so large that they spread over a large volume of space. Therefore, the energy available at any point is insignificantly small and their particle nature cannot be observed. This is clearly seen in the diagram. On the higher frequency side of spectrum, we have X-rays and gamma rays. Their wavelengths are so short that wave energy is concentrated in a small dimension and the particle nature is readily experienced, whereas wave nature is less noticeable. The region which represents the transition region in which both the aspects of light can be observed is the visible region. Hence, we consider light to be having a dual nature. As we are done with the wave nature of light, let's talk about the particle nature also. What these particles are called and what are its characteristics. According to quantum theory, light is made up of special particles called light quanta or photons. A photon is a bundle of electromagnetic energy. It travels with speed of light in vacuum and doesn't have rest mass. The idea of discrete units of energy was given by Einstein, but the term photon was popularized by Gilbert. Now, the question arises, how are these photons generated? Well, whenever an atom moves from excited state to the ground state, it emits some energy in the form of photons. These emissions are random, hence they form a wave train of finite length instead of a continuous harmonic wave. As you can see here, the red ones are wave trains forming a wave pattern moving in a particular direction. In this way, light is considered to be a ray, a wave, and photon as and when needed. So, that's all for today. Hope you liked the video. Please hit the like button and share with your friends. Till then, take care.